Hello everyone, Adam here. Today we're gonna construct a wearable microphone jamming device. So in 2021 it's hard to protect your own privacy, so there are many surveillance devices around you that are basically spying on you. And for example, your smartphone, your voice assistant, they all can do unauthorized recording of your voice. This is an important issue basically on some business meetings, political meetings, for example. There are, of course, some commercial solutions that will help you to do the microphone jamming, for example, like these. But looking at the price, it doesn't look good. So $7,000. And I will show you how to create your own that will basically cost you less than $30. Yes, it is possible. So let's get started. So basically the concept is that you will need to create a device that will uh, do some bias signal on hidden microphones, and in such way that it will prevent them from catching your voice. So to do that, ultrasonic transducers are used. They have to be tuned to the frequency 25 kilohertz. In this, actually, my project is based on this concept. So the one shown here from University of Chicago, and those people they are using some kind of bracelets to generate the signal. Basically, the signal is 25 kilohertz based, as I said. And the important thing is that they are using several boards inside. So this is one that is with the microcontroller. There's also power amplifier, power regulator, lithium-ion battery, and set of transducers. Okay, how my project look like? This is my project, and as you can see, it is composed only of microcontroller, less than 10 resistors, 2 bipolar transistors, some capacitors to block the distortions on the power lines, some coupling capacitor, and set of transducers. So I have tested it with 20 transducers. It can be more, but you need to put here maybe some Darlington block, some set of transistors, but for some initial stage, I think 2 transistors would be sufficient. The issue is that those transistors, they can introduce some kind of distortions. Okay, why those resistors are used for? So this is basically to create a digital to analog converter that will help you to create analog signals. Basically, if there is a 5-bit used here, we can create a waveform like this. So those values will be from 1 to 20 to 31. And I have used an Excel to create a shape of this waveform to calculate those values. So in the code, it will look like this. And what we do, we send these values directly to the port B. So the port B, these are pins for port B, as you can see, numbered from the lowest significant bit to the highest significant bit. We send it here, and it is converted to analog signal that has a sinusoidal waveform like this one. We'll see that in a few minutes. And these 2 transistors are only a class B analog amplifier, so it can be better, but as I said, the project limit was $30. Okay, where to buy those ultrasonic transducers? So you have to go to some Chinese shops like this one and put here a 25 kilohertz, and then you will get a large number of devices shown here. For example, you can buy a set of 10 pieces for $25. I have bought even cheaper than that, maybe something like this. The important thing is that you need to ensure that it will operate on 25 kilohertz. For example, those are operating on 25 kilohertz. There's also some description note here. Basically, you can see here that if you put a sinusoidal waveform with 25 kilohertz frequency, and it will be like 10 volt peak to peak, then you'll get something like 110 decibels of the signal level. So this is very high. The problem is with these transducers that they are very directional. So they have to be placed on some kind of surface like, I don't know, half of a sphere, maybe some bracelet, some necklace, some core, I don't know. So that would be the good approach to do that. So getting back to the code, we get this sinusoidal waveform description and put it directly to the port B, and then it is fine-tuned by some delays to achieve exact 25 kilohertz frequency. Okay, I hope you know now how to do it. Let's look once again on the picture. So these capacitors, they can be different. This is only to block the distortions. This is a coupling capacitor, and that's all. This device will let you to jump the microphones from several meters if you construct it in the proper way. But let's do some soldering now.
Okay guys, now we have a list of components here. So we need some board, we need those transducers as I mentioned, we need those bipolar transistors. One is PNP, one is NPN. So PNP is BC557 and 547 is NPN based. We have a set of 1K resistors, we have a set of 470 ohm resistors to create a DAC, digital to analog converter. We also have a set of electrolytic capacitors to block the power lines and to couple the transducers with the other rest of the design. We also have some capacitor that is blocking power lines. We have some cables. We have 8-pin deep socket. We have Atmel 80 tiny. It can be 80 tiny 13 or 80 tiny 85. We also have some connectors to put on a board to interconnect a set of these, which will be put on a separate board because it won't all fit on the single board. And that's all. Now we start soldering. Yeah, I'm soldering now, and it took me something like 1.5 hours to connect all of these parts. There's a last capacitor to be connected. Also there's some short I have to make to this port, to which I will connect the transducers. And yeah, I don't like this part. However, we'll see what is the final effect soon. Okay, now the final step, I need to check if there's no shorts there. I think everything looks good. Yes, so we have this deep socket for microcontroller here. The 2R resistors are there. And here we have these 1R resistors. We have this complementary pair of bipolar transistors here, the coupling capacitor and the output socket. And here we have the power socket and these capacitors for blocking power distortions. And that's all. And now we're gonna test if this works. Okay guys, so I made one mistake on a diagram. So there should be another resistor, 1 kilo ohm in my case. So after you've done it like I did here, so I had to change this short to this resistor. We can do some testing, and I just wanted to show you that I will be using a power source that is constructed of four accumulators. So basically this is 1, 2, 3, 4. So the amount of voltage is I believe almost 5 volts, 4.8 actually. And the other thing is that I have also done a board with these transducers, so 1, 2, 3, 4, 9 of them are connected in parallel, and I will connect them to my board here, to this point. But before we go further, I wanted to show you how this device really, how this chip really creates a waveform. So if I turn it on and I connect a small oscilloscope, and if I connect to these test pins here, yeah, it should be already visible on the oscilloscope, we have following waveform. I will try to magnify it a bit. Okay, so basically it looks like a sinus kind of sinusoidal wave. Let's make it AC. But if you magnify it a bit, yeah, notice the frequency. So this is the resonance frequency of these transducers. But if you magnify it, you will see that this is the value that we send to the digital to analog converter. So this is why we have some stirrs, something like stirrs here. Okay? But anyway, let's see. I will now switch to the output bridge, and you can see the distortion here. So these transistors, they introduce some kind of distortion, but don't worry, it still be working pretty well. So we'll see that in a minute. Okay, so now it's time to connect all these nice transducers to the device and see how it's jamming the voice recording. Correct? Okay guys, now testing time. You can see my device connected to power source and the set of ultrasonic transducers here, and I have my mobile phone, which is running an application named Spectroid, which shows a spectrum analyzing, which shows a waterfall of spectrum that is received by the internal microphone. Right now you can see my voice here, over here, and now I will switch on the device to show you how it jumps. Now, as you can see, it is completely jumped. This line is almost flat. This is because these transducers, they overload the microphone with the ultrasonic wave, 25 kHz ultrasonic wave, and when I switch this one off, then you can still see the signal. So that is the concept of jamming, and the range of this device is something like 2 meters, maybe more. That will depend on the number of transducers that you have put to this board. So I have this board here, the transducers are connected in parallel. And now let's see how it works when someone will try to record your voice. So let's now go to the application to voice recording, and yeah, and now I will switch this one on and I will count to 50, and you will observe while I'm switching on and off the device how the signal is jumped. I will then play it back for you to see how it jumps. Okay, let's start now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Okay, I have it now recorded, and now I play it back and listen. 1, 2, 3, 4, 5, 6, 12, 13, 14, 15, 16, 17, 24, 25, 26, 27, 28, 35, 36, 37, 38, 39, 40, 41, 48, 49, 50. Okay guys, now you see how it is jamming, so remember that if you are trying to construct such device, please do not do it like this in flat way. So this is wrong. You have to do it in a way, I don't know, something like sphere, or maybe some bracelet, or maybe some necklace, but not like this. It is just to show you how it jumps, because I can then steer the direction that I want to jump. Okay, this is not a good approach to build such kind of machine. Remember, use a different shape. The best would be some kind of spherical one. Okay guys, so I hope you enjoyed this little video. Remember that the cost of this whole device is less than $30. Basically for this one is even 20 or maybe less. And remember to protect your own privacy, ban some voice assistant, and hope you like this video and you build one from this. And bye bye. Please press a like and subscribe my channel. Thank you very much. Bye.